an angle called an angle of elevation. Which, by the way, today you're going to show off your artistic ability to me. This should be good. Mine is awful. Probably the worst in here. Worst in here by far. But anyway, here's elevation. You are on the ground. All right, let me just start off with that. That's about as best as I go there. You are on the ground looking up at something. All right, forming an angle. So it could be a building, could be a tree. So let me throw my building up here. A couple windows, obviously. All right, and you are looking at something up the top of the building. You form an angle. Your eyesight looking up forms one side of the angle. Where's the other side of the angle come from? Your horizontal line of sight as well. So everyone see that angle form down there? That is called your angle of elevation. You are always looking up along with your horizontal line of sight. And then take a look. Here is our right triangle that we end up making that we can do sine, cosine, tangent on. So the elevation, ground, looking up at something. Look it up. So look at Big Scott here on problem number 1. How about that diagram? I can't take credit for that. His eye level 1.5 meters above the ground, and he's standing 30 meters from the tree. You want to throw those numbers on your diagram somewhere? His eye level 1.5 meters above the ground. So ground to eye is 1.5, and he's standing 30 meters from the tree. So let's throw that 30 meters on there somewhere, right? He is 30 meters from the tree. All right, here's our term now, one of our 2 new terms today. His angle of elevation to the top of the tree with the bird is 36 degrees. So again, ready? From his eye level, all right, from his eye level to the bird, along with his horizontal line of sight. See that angle I'm forming is 36 degrees. 36 degrees. That's angle of elevation. And see the right triangle we can make out of it now. Draw that vertical line down. I have a right triangle I built with an acute angle. Ooh, here's the question though, and I'm going to have a little issue with it. How far above the ground is this bird? All right. From here down, what's that height there? All right, before we do anything, if we're going to use sine, cosine, tangent on that right triangle, I at least need to know a side length. I can't go 3 missing sides. I at least need to know what one side is. So looking at everything we labeled, can you tell me what one side length would be now? Right, after everything we were given, what's one side length up here? Let's roll 3 again. Aiden, what do you got? What's one side length you're pretty positive on?
30 meters.
Yeah, 30 meters right down here for this leg. Yep, 30 meters. But the second issue I have, you can help me out with, is, hey, if I find either side of the right triangle, either of the 2 missing sides, that's not going to be my answer because I need to find the whole length from bird to ground. Is there any way you guys can help me out here? Because if I find this side, that won't be the distance. If I find the hypotenuse, that won't be the distance. How can you help me out here? Everything's given for a reason. How can I find the length of the bird to the ground now? Bird to the ground. Any thoughts? Thoughts? There we go. Let's pop it out. Thomas, thoughts?
The eye level is 1.5 meters.
Yep. And what can I do with that?
Add it to the opposite.
There you go. I am going to find one of the sides. I'm going to find the opposite side here. I'll find the opposite side and then add it to 1.5. Good. Everyone all right with the plan? Okay, so Thomas already gave half the story away. It's the opposite side we're looking for. What's the 30 though? What's the 30? What side would the 30 be to the 36? 30 would be Amy?
The adjacent.
Adjacent side. All right. You guys hopefully know how to spell SOHCAHTOA or just know it by now. If I have the opposite and the adjacent side, which one of the 3 ratios can I use? Ian? Tangent. Yeah. Tangent got no love on day 1. It's going to get a whole bunch here today. So tangent of 36 equals your opposite side over I did it again. Over adjacent, TOA, T-O-A. Make sure your calculator's in degree mode, even though that you guys are the 4th group to use them today. Put it over 1, cross multiply. Tangent of 36 times 30. Is this going to be my final answer? No. Why am I asking you that? What are we not doing here at this point in the problem? Rounding, correct. We are not rounding this right now. We're going to write it all out. And then we can add our 1.5 to the non-rounded answer. I don't want to call it x again because I already called that side x. I'll just say distance equals. When you have it rounded to the nearest tenth, let me know. Haley!
23.3.
Good job. And again, you guys know I said this a lot already. I'm not going to penalize you if you have units or you don't. Angle of elevation. We good. Looking up with your horizontal line of sight. All right, let's flip spots now. The second term I need to go over with you is called angle of depression. Angle of depression. Now, you're on top of something, a building, a tree, a ladder, a cliff. And you are looking down on something. You're looking down. A dog, an ant. I'm not too sure what that is, but that's as good as I get here. There's a reason why I took woodworking in high school and not any of the art classes. All right, so now you're looking down, but here's the thing I need your help with. Watch what happens. When we do angle of depression, ready? You're looking down on the object along with your horizontal line of sight, like elevation was. So look where the angle of depression is. And maybe you guys can help me with this problem. As I draw this right triangle, look where my angle of depression is. It's outside the right triangle. So that means if I wanted to use sine, cosine, tangent, I cannot use that angle. I can only use an angle and an acute angle located inside my right triangle. So is there any help you could give me? Hey, if you know the angle of depression, even though it's outside, here's what you could do with it to find an acute angle inside. So if it helps, I'm just going to randomly say this is 30 degrees. Angle of depression 30. Can't use 30 though. It's got to be inside. It's got to be an acute angle inside my triangle. Is there anything you could do with that 30 to find an angle maybe inside? Because Nia, what do you have?
Would it be like the angle that's like near the whatever it is? It's like
Use your big word.
okay, alternate interior.
Oh, down here.
Yeah.
Okay. Yeah. Okay. You were going to say whatever that thing is. Yeah, I get it. So yeah, she's saying, hey, if that's 30, I remember my alternate interior angle days. That's got to be 30. Correct. Or was anybody thinking about the adjacent angle next to it? What's the relationship between my angle of depression and the adjacent angle? They are? Oh, I love using the words. Complementary, yes. So you got a choice. Use the adjacent complementary angle or the alternate interior congruent one. Okay, your choice. But again, when we set up an angle of depression in a word problem, it's got to be on the outside. Then you decide what you want to do with it. So let's go to our boy. Here it is, Big Al. He's on top of the building, his building. And he's watching his friend approach the building. That's a little creepy, but whatever, we'll roll with it, right? His angle of depression is 40. So he's on top, ready? Looking down. Don't make the mistake. This angle is not 40. It's that angle looking down with our line of sight, horizontal line of sight. So draw in the horizontal line of sight. That's 40. Okay? Angle of depression, never located inside the triangle. All right, here's our right triangle. Here's our right triangle. We got a couple values to add to it. Let's see here. The rooftop is 16 meters from the ground. So rooftop right here. This distance here, rooftop to ground, is 16 meters. And then take a look. We say his eye level is about 1.8 from the rooftop. There we go. What's the distance between his friend and the building? So building is right here, friend is right here. Make sure we're solving for that side, right? We're not looking for the distance between the two. Between Big Al and his friend. Big Al's friend in the building. All right, you make a class decision right now. What do you want to do with the angle of depression? So it's inside the triangle. Your call. We just described two different techniques. What do you want to do with that one? Aiden, your call.
50.
You want to do the adjacent angle? You got it. So we'll use 50. Still going to get the same answer. Even still going to use the same ratio if you use the alternate interior. All right, so if I'm using the 50, what's the side we're looking for there? X. Josh, what's that side we're looking for? Compared to the 50. X would be opposite. Good. And this side here, which is combination of the rooftop and his eye level, would be what side for us? 16. Why do I never? Zeev. The rooftop.
17.8.
Okay, it is 17.8, and that would be what side? If I'm using 50. Adjacent. Yep. So we should be using tangent. I don't care if you use the alternate interior angle. You should be using tangent as well. Tangent, and Zeev gave it away already. Stole my smoke. Make sure we're using 17.8 for your opposite or adjacent side there, not 16. All right, that's not the full side in my right triangle. The only difference is if anybody use 40 as the alternate interior, you'd have 17.8 over X. You'd have the reciprocal instead. Still going to get the same answer though. And how far is Big Al's friend from the building? Nearest 10. Thomas again.
21.5.
Yes. Yes, indeed. Good job, young buck. Go to number 4 now for me, please. Number 4, because you guys are going to be doing these two problems in your group. All right, you're going to be doing these two problems in your group. But number 4 has a vocabulary term. I want you to know how it fits into the word problem. All right, so we got a control tower looking at an airplane. I can't wait to see some of your control towers. I can't wait. And yes, I'll be walking around being critical of them. Peace. There you go. Control tower, airplane, right? Just so you guys can get an actual visual of what we're talking about. You can read through it. There's just one term I want you guys to be aware of, and that is the 5,200 feet. That's the altitude of the plane is 5,200 feet. What that means is wherever the plane is on your diagram, directly down to the ground is 5,200 feet. Okay? So that's what the altitude means. Wherever the plane is, directly down to the ground is 5,200 feet. Okay? And then it's got 7 of you guys can read through it and fill it in from there when you get to it. But I just wanted to make sure we are good from here down 5,200 feet, plane to the ground. All right, good? Okay, you guys can work in your groups on numbers 3 and 4. I'm going to write the answers up here. Make sure you got the correct answers, and then you can go right to the homework. If not, you know the deal. Call me over. Guys can talk. It's all right.